Hello everyone, my name is Agnese Salvati. I am from Brunel University, London, and the study is titled Impact of Urban Albedo on Microclimate. So, urban albedo is a variable defined as the ratio of the outgoing to the incoming shortwave radiation at the upper edge of the urban canopy layer. In few words, it measures the ability of urban areas to reflect shortwave radiation toward the sky, which is affected by the multiple solar reflections within urban geometry and by the optical properties of urban materials. So the final aim is to increase urban albedo in order to reduce and mitigate the heat island effect. In this study, I'm going to show some relationship between urban geometry, optical properties of facades and roads materials, and urban albedo and microclimate at the street level in high latitudes. In particular, we investigated a typical residential area of London by using a physical model reproducing the urban area and performing microclimate simulation with ENVIMAT. These are some views of the case study area, and on the bottom you can see some pictures of the 1 to 10 physical model cladded with real building and urban materials. The physical model is equipped with pyranometers measuring the incoming and reflected radiation on the top of the model and at the eaves level of urban canyons, so to measure the reflections within urban canyons. These measurements were used to assess the accuracy of ENVIMAT calculation of reflections within urban canyons. And to the same, the simulation of the same geometries and material were performed with ENVIMAT, and the reflected radiation from the lower hemisphere, which is an output of ENVIMAT, was compared to the reflections measured by the pyranometers on the scale model. The comparison showed that ENVIMAT generally performs well. There is a slight underestimation of the reflections within the urban canyons. On the other hand, ENVIMAT overestimates the reflections on top of the model, so when also the reflections from the roofs are taken into account. But the overall performance, so the daily urban albedo calculated by ENVIMAT, is in very good agreement with the measurements on the scale model. So a second step of this research was aimed at assessing the impact of reflective materials applied to facades and roads to the overall urban albedo and the microclimate at the street level in London. We developed a more detailed ENVIMAT model to perform this assessment, and we tested different strategies. One strategy applying reflective material to the facades in different ways, only to one of the two facades or to both facades, but only on the top half part of the facades themselves. Also, we tested the impact of reflective materials on roads, and we simulated these strategies for different urban geometries. The results showed that the impact of reflective materials in urban canyons is not so straightforward, let's say. First of all, they have a larger impact in low-rise urban canyons. And then the strategies that have the highest potential to increase urban albedo are the application of reflective materials to the roads in low-rise urban canyons and the application of reflective material to the top half part of the facades in high-rise canyons. And a further assessment of the impact of reflective materials was aimed at checking any negative impact on the street level microclimate, because the increase of reflection determined by reflective material in most of the time determines an increase of the mean radiant temperature, which is an unwanted, let's say, a consequence of using reflective materials to reduce heat island effect. And we verified that this happens in all the cases except for the scenario in which the reflective materials are applied only to the top half part of the facade. So in this way, we can have an increase of the overall urban albedo without compromising the street level microclimate. So this is probably the best strategies to mitigate the heat island effect without any negative impact on the street level microclimate in London. So in conclusion, the evaluation of the MVMAT IVS algorithm showed that the detailed algorithm for the computation of reflections performs quite well compared to the measurements. And we also proved that the most effective strategies to increase urban albedo are the use of reflective materials on roads and on the top half of the canyon facades. And finally, this last strategy is probably the best because it also avoids any unwanted increase of the mean radiant temperature at the street level. So this is all for me. Thank you very much. And for any question, please email me. Thank you.